Welcome to Dependency Injection in .NET 8. Before diving into the implementation of the dependency injection design pattern, let's first understand what it is. Dependency injection stems from an important object-oriented design principle which states that concrete classes should not directly depend on one another. When classes are tightly dependent on each other, we describe this as high coupling, which makes the code harder to maintain and scale. On the other hand, when classes minimize their dependencies, we achieve low coupling, resulting in cleaner and more flexible code. Now let's understand dependency injection with the help of code. Alright, I am using a console application in .NET 8 to demonstrate the dependency injection. Here's an example of tightly coupled three-layer architecture where we have the user interface, business, and data access SQL classes. The user interface takes the input from the user such as a username and password and register them by passing the information to the business class, which applies some business logic and sends the data to the data access SQL class, which inserts the data into the database. However, in this example, we are creating the object using the new keyword in the register method of the business class. And this creates a problem. In case if we want to switch the database from SQL to the Oracle, then we have to create the object of the new class or modify this method. Let's create one class with the name of the data access Oracle, and then replace with data access Oracle. And if we want to use this data access Oracle class, we have to create the object in the register method of the business class. This happens because one class is directly dependent on the another class. If we want to make any changes in the business class method, then we have to modify the user interface class. This is also called a high coupling. So this tight dependency is also called a high coupling, and it makes the code harder to maintain or adapt to changes. To reduce the dependency, we can use the interface and constructor. So first we will create the interface for the data access classes and business class. Public interface, and let's take the name iDataAccess and declare the register method, and this iDataAccess will be implemented by the iDataAccess SQL class and data access Oracle. Likewise, we can create the interface for the business class. Public interface, and let's take the name iBusiness and declare the register method, and business class will implement the iBusiness interface. we will modify our business class and the user interface class to implement the constructor. So we will create the constructor for the user interface class and the business class because we are creating an object in both of these classes. So let's create the interface for the business class with the parameter of interface type. But before doing this, we can take one private field with the type of interface type. Private I data access, and now create the constructor public business and pass the parameter of the interface type. So that is I data access, and pass the data access variable in our private field variable. So here you can see that we are creating the object, but we can now comment this one, and our private field will create the call the method of the register of the data access class. So by using this approach, we no longer need to create objects inside the class. Instead, the dependency is provided from the outside when creating the object of this class. For example, when someone creates an object of the business class, they must pass an implementation of iDataAccess. This makes the system more flexible and reduce tight coupling. Now let's create the constructor for the user interface. Private, and here we take the iBusiness type of variable, and then create the constructor public user interface, and then pass the parameter of iBusiness. Okay, and we can comment this line. Okay, so here you can see we are not creating the object inside of the class. Now let's call the register method of the user interface to check if the code works properly or not. Before that, we will create the object of the data access and the business classes and reference them using their interface types so that we can pass them as a parameters when creating the business and user interface object. Okay, so let's take the iDataAccess and variables data access and create the object of data access SQL. Next, create the object of the iBusiness and reference them to the iBusiness reference interface type. Okay, here you can see that we are passing the iDataAccess interface type in the parameter of business, like while creating the object of the business class. Similarly, we can do it for the user interface. Now let's call the register method. Okay, so we have created the object and call the register method. Now let's build this program or run this program and see whether it's working or not. So the command is .NET run. Okay. So our program has started, and here you can see is asking the username. So let's give the username and then password, and it print the insert data into database and user register successfully. So we successfully created the object outside of the classes and injected the constructor. However, we are still using a new keyword to create the object. To eliminate the use of new, we can leverage the dependency injection capability provided by the .NET. So first we need to add Microsoft.extension dependency injection NuGet package to our project. Okay, so the command is to add the package is .NET add package Microsoft.extension.dependency injection. I have already added in my project. So if I go to the proj file, you can see the reference of the Microsoft.extension dependency injection package. So first we have to add the namespace in our program using Microsoft.extension dependency injection. So once you add this namespace in your code, so this basically gives access to the iService collection interface, which has the implementation called service collection. I have already created the code of service collection and to create the object from that. So let me put it over here, and here you can see we are using the iService collection. So using service collection, we map the interface to their concrete implementation to data access SQL by calling the add scoped. There are other methods like add transient and add singleton, but we will learn about their differences in the next video. For now, we use the add scoped to register the iData access with data access SQL and iBusiness with business. And for user interface, we directly registered using add scoped, as this class is not implementing any interface. After registering all the dependency, we use the iService provider to use our dependency, which we created by calling the build service provider on our iService collection. The service provider automatically creates instance of the registered class when needed. For example, instead of creating the user interface object manually, we can get it from the service provider, like this user interface UI equal to provider.getService and passing the user interface. So when the user interface calls class requires iBusiness as a dependency, the service provider automatically provides an object of the business class without requiring us to pass it manually. The same applies to the other dependency like data access. So when we run the code, the dependency injection system handles all object creation and dependency injection. So we can remove this previous code where we are creating the object of our classes and run the code. Let's save this program and run the command. Okay, the program has started and we need to give the input, that is the username. Let's give the username and password, and it print the insert data into the database and user registered successfully. So our program is now working properly. So I hope you got some understanding of the dependency injection. Thanks for watching the video.